Alright guys, so we're back. Um it's been 2 days and we're gonna be working on the network now. I had to take a little break, but we're gonna get right back into here. We left off right here, where it says neat genome. We got done with the genome so far. Obviously we're not done with it completely because we have to add some mutation and some different things to the genome still, but so far we got this genome done. So let's look at the editor and see if there's any errors, which there is. I knew there was right when I ended this video. I saw the error and I was like, oh no. But here we go. Let's fix that. So congene, we just misspelled it. It should be congene. The gene is capital. The G. Now find where. Right there. Alright, let's go back, see what other errors we have. It looks clean. Alright, nice. So far that genome is done, and now we're going to create a new C# script and call this the NeatNetwork. Alright. We can see NeatNetwork right here. Again, we don't need any of the start and we don't need any of the mono behavior. It also means we don't need that. But I'll keep that for now. Okay, I've said this multiple times before, but I'll say it again. I'm looking at reference code, which is right here to the side. And we're going to kind of follow this as a guide to what to do, basically. But looking at the neat paper, we have the genome basically made. We set up all this input, output, weight, all this in our class. And we are our genome class has a list of node genes and connection genes. Sorry about that pause. I looked at my phone for a second. But node genes and connection genes, right? We take these node genes and connection genes and we use them to create a network. We basically we create our network is also going to have edges and weights, but they're going to basically be mirror values of these. Okay, so in our neat network, first we need classes that represent our nodes and our connections. Call it node, and in node we go to my reference code, go down. In node, it's going to look similar to the genome, right? It's going to look similar to this, except that it's going to have values. So we'll keep these public. ID just like we had in the genome. But we're not going to have a type for the node because our genome will tell you the type. Okay, there is a way where we could just put the type in the node, but we don't have to do that. So we won't do that right now. Value is the value is the float value that's actually going to be stored in the node, which then gets fed forward during the feed forward loop. So like after being multiplied, the value gets multiplied by the weights and then put into the next node's value, which is why it's called feed forward. You're taking value from one node and feeding those values forward into the next nodes. So one thing that's interesting when we're going to have a node, we also want a node is represented by itself, by its ID, its value, but also the connections that are attached to it. Okay, so if you look at 5, we see that coming from the bottom, we have 2 connections that point to 5, and then 5 points to 4. Okay, so 5 only points to one connection moving forward. For 5, we can see that the input nodes, the nodes that are giving 5 input, are 1 and 2, and the output nodes, which are the nodes that are getting the output, are is 4. Okay. So let's now move back to the code. Let me find it. And let's make a list. Well, we first have to make connections. But then in our node, we're going to create a list of input nodes, input connections, and output connections, which are basically going for so that each node knows what connections it is pointing to and what connections are pointing to it. Okay? So let's create that connection, and our public connection class is going to look similar to our connection class in the genome as well. And then the connection class will have the public int node. Let's spell it out. Okay. Input node, output node, public float weight, public bool is active. Okay, so that should be good for the connection gene. Let me again look at my reference. This is very interesting. For some reason, my reference code, I have an input value in the connection class, but there's really no need for me to have an input value for my connection class. So I'm going to leave it as this right now, and then in the future we will see why that's there. Like I said, the code that I wrote here, it's not perfect, and that's the whole reason why we're writing this cleaner version, this version that is more easier to use. I learned from my mistakes, and I would like to fix those mistakes basically because this is not then going to be used in future projects, so it has to be neat. Okay, now that that's done, we can make the list. So we can have a public list of connections, we call it input connections, and a public list connection output connections. All right. So our input and output connections will basically tell us the flow of how this is going. So let's take for example, if we have node 1. Node 1 right here will have no input connections, but it has 2 output connections. Okay? And that is shown right here. So int is 1, out is 4, right? So the output connection of 4, this connection right here between 1 and 4, will get put in the output connection, and then this will get put in the output connections as well. but nothing will be put in the input connections for the for the first node 1. Okay, but node 4 will have these three connections in the input and nothing in the output. So that's how that's going to work. And then that's pretty. We just have to make the constructors, but that's pretty much done. And constructors are easy for this. Because when we're creating a node, all we're going to pass it is an ID. And then we're going to do ID equals ident. And then that's basically it. When we're creating the node, we just give it an ID. As the connections get created, then we put the connection in the proper node. So we're going to add the connection to the proper thing. Okay, and this isn't done yet. We're going to add the ability to feed forward for each individual node, because each individual node is going to be feeding information forward to its neighbors. So we have an outer loop that goes through 1, 2, 3, but then inside 1, there's a loop that feeds information forward to all output edges, right? So the 1 times all the output edges, and that value gets put into the output edge. Okay. So we're not going to make that yet. We're going to first set up our network, and then we're going to create more on the network. All right. So let's now set up the variables for the NeatNetwork, and then we'll start doing some functionality for all these classes that we have. Okay, because again, Node still needs the functionality of feeding information forward, and we need to add the activation function that's being used for each neuron, which transforms the output as well. So when we're creating a network, we have to have, each network has to have a neat genome, which is the class we created right here. Okay, because each network is created from the genome. The genome is the blueprint, and the network is the building. Well, in this case, the brain. But you know. So now each network. So this is really where we're building the network. So each network will have a list of nodes. So we know how all the nodes that are in the network. We're going to have a list of nodes again. But this time we have input nodes. And since we're going to keep a list of all the input, output, and hidden nodes, we don't have to inside the node define if it's an input, output, or hidden node, right? But you could do it that way as well. If you do choose to put your whether it's a hidden node or not within the class, within the node class, then when you're looping through it, you're gonna have to make sure that you know where your hidden nodes begin, where your input nodes end, and where your output nodes begin and where they end. Okay, when you're looping through. So usually you would pass input, output, or whatever that you get from the genome. But I would say just follow what I'm doing, and then in the future, just play around a little bit. Because I've done a couple of different ways in this, and this is just, but everything was done a couple of months ago. I'm a little rusty right now. So we have our input nodes, output nodes, and now we're going to have our hidden nodes. See, I've been using Python, and that, like, since you have so many data science libraries already, it's a little bit easier to code this. And in the future, I will be coding Neat in Python, so that's something too. Hopefully, that's going to be a lot cleaner. This is a little longer because there's just a lot of moving parts to this. So, okay, there's output nodes and hidden nodes. Alright, so we have everything for our nodes. Then we have a public list for our connection. I really, really hope. Give me 1 second. I want to make sure everything is lining up properly. Yep, all good. And then connections. Connections. Alright, now we're going to create the constructor for this, because that's basically, with these variables, we know everything we need to know about the structure. We have everything we need to create the structure of the network. We also, since we're going to be using a genetic algorithm to be, since Neat is a genetic algorithm which relies on fitness, each network also is going to have to know what its fitness is. So we also have fitness, but for now we're not really going to worry about this. Okay, the genetic training part will come after the network is made. Okay, so after we can manually create the network and manually implement weights and see our fish moving with a manually created network, then we can work on training of that network and building it through code instead. So we have that done. Now we have to create the constructor, which is going to be int input, int output, int hid. So one of them, when we create the network, we're going to do it we're going to take input, output, hidden, like that's what we're going to be passing the network ints of how many input nodes we want and how many output nodes we want and how many hidden nodes we want, because we can start off with hidden nodes. We don't have to start off with no hidden nodes. We could start off with as many hidden nodes as we want and keep training. It's just better to start off with as few as possible. But to have the ability to start off with more is better, because sometimes you know how many you need. Okay. So we have input, output, and hidden. Input nodes, output nodes, and hidden nodes. And then when we create the network, we want it to first, we're going to get the I'm gonna have to take a look at this. Give me 1 second, guys. So when we're starting with just input and output nodes, input, output, hidden nodes, we're going to want to start by creating a network. So instead of putting everything in here, we're going to put, it'd be better to put it in a function, so it's a little bit cleaner. But this function is a private function, which returns a genome. So as you see in this, we don't have a genome being given to us when we're creating this. So we have to create a genome based on this, and then use that to create the network. All right. So we have private neat genome, and then so we're going to be returning a neat genome, and the name of our function is going to be start create starting genome. Yeah, I guess that's a good enough name. Actually, let's call it create. Sorry, my name, you can some things I want very much to match up with my code, with my reference code, and some things I want to do better. This is one of them, with naming and having more meaningful names. So we're going to do create initial genome, and that's, to me, a more meaningful name. Okay. And then in this, when we're going to be doing this, we want to also have the input basically we want all of these right here. All right. And then now that we have how many input, output, and hidden nodes we have, we can begin to create the create our nodes. All right. One thing the nodes, we could begin our genome creation, not a node creation, our node gene creation, and connection gene creation. So we are initializing the genome, okay, by creating a brand new one. So when you look at the genome, right, we start off with just an empty list. So let's do that. Genome equals new genome. And that is good for initializing. Let's save and make sure, see what errors we have. We shouldn't have any errors so far. But we do. Alright, that makes sense, because we're not returning the neat genome yet. And we could just return that right there. That should be gone, and everything's looking clean. So now in that, we have to populate the genome with initial values. Okay? And since this is an initial genome, the weights of the values will be random. So if we have any connections, the weights of those connections will be random. It should be random, or start off at 0. And that's about it. That's about it. You just create how many nodes you want, and I'm not going to create any edges here. We can also create your if you want edges to begin with. Let's say you want a completely connected network when it comes to just having input and output nodes. So you have just input and output nodes and a completely connected network to start off with, and then you train by adding nodes and adding edges once more nodes are added in. Okay, because you can't add edges if you have a completely connected network, but once through mutation nodes are added, it makes up room and increases your search space. So let's get the loop going. But first, we're going to create a list of node genes, because what we're going to do is going to just create node genes, and then in the future, you know what? I don't like the way this is set up. What we're going to do is we're going to add another function to our neat genome. So from here, don't finish this line. We're going to leave this network right here and open up the neat genome. These two need to be open side by side, and the fish controller should also be open, so you can quickly go through these three. Okay, because we will be jumping back and forth. But so right now I'm letting you know we're going to go to neat genome, and we're stopping right here for the create initial genome right here for now. So we go to neat genome, and over here we're going to create another constructor, override that one. So now if we get list of node gene, node gens, and list of con genes, con gens, then we can just initialize the network right off the bat like that. So we don't have to so that we don't have to individually add nodes to the node genes and the con gene. So this will be node genes equals node gens, and con genes equals con gens. Okay, so that's good right here. Let's move back to our NeatNetwork code, and before we do anything, let's open up Unity to make sure there are no errors. And there are errors, so let's fix that. Oh god, no. Let me go right back to the code. Con genes, of course. So get rid of that S, save again, and it should be good. Okay, so now that that's good, we can begin creating, so instead of having to add our stuff individually, we can, instead of adding our input, output, and hidden genes individually, we can now just create a list. So, no gene, new node genes equals new list of node genes. Okay. We're gonna copy that con gene on genes con gene. So we create a list of node genes and con genes, right? And now we have to populate them. So I'll click an easy for loop. I is less than input I plus plus. Should be good on that. I don't know why that did that. And yeah. Let me make sure the loop is going, wow, the index is right. Yeah, everything is good. Sometimes I get messed up with the zeros and ones. Yeah. What can you do about that? But this is good right here. Everything's fine. So let's now create a node gene node gene oh my god. So node gene, and it's going to be new node node gene, because this has an S since it's a list. This is the node gene that goes inside node genes. That's usually how I name things. So new node genes equals new node gene, and we will create that with an ID. Oh, so we also have, since we need an ID, which is the one thing that we pass to our node gene. Oh, and type. Okay, good. We need a type and an ID when we pass to the node gene. The ID we're going to have to create right here, and we're just going to create a count. ID equals 0. We're going to start off with a 0 count, and we're going to add to it after every loop. So now we can have node ID start. So node ID will start from 0 and then work its way up. So it's gonna get, and then we're gonna get the type. So for when we're getting the type from an enum within an object, we have to reference the object, and then oh my god. I'm going to have to probably disable that, and hopefully that does it. I don't know. Node gene. This is gonna get old really fast. So we're gonna just copy and paste that dot type, and then you get that right there, dot, and then the given type. So we're going to do input for the input nodes, right? So now all the nodes in this node gene is going to be input node genes. All right, and it's given the proper count as well. Now we need to add this to the list. So new node genes dot add new node gene, and that's perfect. Next, we just copy and paste. This is what we copied and pasted, and now instead of going to input, we go to output. Okay. Interesting enough, you want to have your input, then your output, and then your hidden nodes, because then you can just keep adding hidden nodes at the back of your list. Okay. If you have your input and then you want your output at the end of the list, you're gonna have to keep adding hidden nodes to the middle of the list. So just little tip. So again, we're gonna have a node genes. New node gene is same thing. New node gene, and then we follow the node ID, which is going to keep on incrementing. So we have new node ID, and but the one thing we change is that this is now output. So all the outputs get the type of output. So new node genes, new node gene, we add it, and we increment again, but the last one we don't need it, so whatever. So once everything is added, now instead over here, you see how we created the new genome? We're gonna cut that out. So Control X to cut, and we're gonna paste that right here. Okay, so instead of creating the new genome up on top, we no longer create it up on top. We create it at the bottom, and instead of creating an empty a new genome, we pass it new node genes, and we pass it new con genes. And that way, now our new genome has everything we need for the network to be created off of it. So our blank genome is created, and then our blank genome is used to create the network. Okay, the initial network. Let's save and see if there's any errors. Yep, no data does not exist in the context. Why do I keep doing that? I can't be double clicking on that because it opens in whatever that is, that text editor, whatever. All right, so where I'm going up and down and all around. Huh? This is the creation of our initial genome. All right. Oh, let me fix that error also. ID just the connection forms, and that should be good. This is the creation of our initial genome. We use this inside of our constructor. Give me 1 second. All right. So now let's make sure the errors are fixed up. Errors are gone. So we should be good to go. And let's set up our genome. So when we do in our constructor, we want my genome to be created with create initial genome, and then we pass it the input, the output, and the hidden nodes, how many we want. Okay. And yeah, so that creates our genome. And next, within our initialization of the network, we want to just create new list for the we just want to initialize the list for the nodes, the input nodes, and the output nodes. Okay, because we haven't yet created our network. So nodes equals new list of nodes, and we're just creating blank list. Input nodes equals new list of nodes as well. So that one's for the output nodes, and that one's for the hidden nodes, and then this is going to be for the connection nodes. And we don't have to worry about setting fitness yet. I believe for now I'm going to take this. We have fitness here, but I want to take that out for now. I want to add it when it's the proper time to add it. So let's sorry about that. Let's just take that fitness right out of the code, and our code is now looking like this. My genome, so on. Just getting rid of that fitness, and yeah. So input nodes right here we'll have output nodes. Right here we'll have hidden nodes. Right here we'll have connections. Yeah. Okay, but for the connections, change the object. And that's looking good. That's looking great. The last thing now that we have to do is simply create the network. All right. The creation of the network is going to be done in another function. This is also going to be a private function, but this function doesn't return anything. Let me just make sure I have everything for it. So void create network. And this is where the network gets created. Okay. one thing that is interesting is that when we create a network, it's going to be done every generation. So whenever we create a network, there might already be there might already be a network created, and if we call create network again, we have to reset anything that's inside the nodes and connection genes beforehand. Okay, but for right now, I'm not going to do that. We're going to do that when we implement the genetic manager and have different generations implemented. Okay, for right now, we're just going to create the network. So the network creation is actually not that hard at all. We do a for each loop, and then we loop through the gene. So we loop through every node gene in my genome dot node genes. Okay, and that gives us that big loop gives us basically everything we need for the nodes. Okay, and then we need to have another loop for everything for the connections. We're gonna write that, and what we're going to do is write the loops that we need on the outer side, and then we're gonna write the logic inside for each loop. Okay, what's happening is that we're basically reading through our genome and setting up, building our connections. Filling in the list that we created in the initialization right here. Okay. And in this initialization, we know that the my genome has been populated because it's been passed. This has been called right before it. So right here we do create network, right? And that is going to call this function, which will create our structure for the network. So in this we have to create a node. Oh, let me finish this. Yeah. So we're gonna write the outer loops for each of these first, and then write the inner logic. Okay. So for each con gene in my genome dot con genes, and then so this will populate our node list, right? So in here, this loop right here will populate our nodes, our input nodes, output nodes, and hidden nodes, while the second loop right here will populate our connections. All right, we need one more loop to populate our input connections for each node and output connections for each node. Okay, so we have another for each, but this time we're going through node, right? Node in I believe it's nodes. Let me make sure. Yep, nodes right here. So for each node in nodes, we're going to want to populate the input and the output. Okay? And now let's set up the logic for this top loop, then this middle loop, then the bottom loop. Okay? The top loop, we're going to have to create nodes, which are then going to be populated with the value of each node gene. So we can say right here, node gene get ID. Nope. Since we're not using since we made everything public in this version, we're not using any of the getters and setters. I actually, in my reference code, everything has getters and setters. Everything is it's very dirty, honestly, and that's why one of the reasons why I'm changing a lot of the code. So since we're going to be getting the ID, we're going to be going nogene.id alone, and that should be good. Then we simply to start off with, we add the new node. All right. Because right here, as you can see, we don't take anything. We don't take a value. The value gets assigned during our feed-forward loop, and we haven't assigned input and output connections because we assign input and output connections in the loop right here. Okay, so that's why I wanted to write these 3 loops out. I wanted just so you guys could see that how we're populating, how we're building the network off of the genome. So right now we start off with just setting in the ID and for the node and adding it to the node list. But now we need to also add the node to the list for the if it's an input node, or if it's an output node, or if it's a hidden node to the specific list that it belongs to. To do that, we're going to have an if-else statement. If node gene type, I believe I made the type public. I hope I did. Public, yep. If nogene.type equals nogene dot so if nogene.type equals nogene dot type dot input, so if the node gene we're looking at type matches is input basically, so this is saying that it's input, then we want to add it to the input nodes list as well. And we do the same thing then for the else if. But now we change this from input to hidden. Okay? So if the value is input, we add it to the input nodes. If it's hidden, if the type is hidden, then we add it to the hidden nodes and then the output. I don't have, I could just say else, but why not just say else? The output nogene.type, the output will have the yep. Let me make sure this looks okay. Type dot hidden, type dot output, dot input. Everything is looking good, and this is just populates our node, all our node stuff. Okay, so all our node list, our input nodes, output nodes, and hidden nodes. Okay, that's done. Now we have to do our code for the next loop. But before I do that, I want to check to make sure that there are no errors. Which there are. There's always errors. Ah, rookie mistake right there. And that's, yeah. Okay, good. At least it was a simple error. So everything looks good in this loop. Please make sure that you use the double equal sign. But I'm sure you guys are, you guys saw that. So good. Now let's move on to the connection gene loop. All right, which is going to be similar to the no genes, except we don't even have any type. So really, it's just going to be initialization of the connection gene and put in right here. Okay? But the thing with the connection genes is that when you're initializing it, you need to have a weight, right? And we get that weight from the genome right here. So we have the weight right here, and we set it in this. So let me write this, and I'll show you guys how it is. And you guys will see how this is basically just a mirror of the connection genome. And all this is just, even up here, we just put the ID from the connection genome. So we're literally just mirroring the actual structure based off the genome, which is really cool. That's kind of how DNA is working too. We have to create the connection, but when we're initializing the connection, we have to make sure we pass everything from the genome right here, from the con gene that we're looping through. Let me see what everything is in our con gene. Input node, output node. Wait. So, oh, I forgot to write the constructor for the, okay, good. Let's finish writing this line, and then we'll write the constructor that, this line is supposed to, call. Alright, because we didn't write the constructor for the connection gene that's supposed to, this line is supposed to be calling, my bad. So we pass it and just the, active. That is active. Because we have no types or anything that we have to worry about, nor do we have any values, just the weight. And so now that we know what we're passing it, go down and create the public connection constructor. And that's looking perfect. And that's looking good. So after the new connection is created, we then add it to the connection list. So connections, so what we call it up here, connections. So connections dot add new con. Let me check my reference to make sure everything is looking good. Yep, everything is looking good. And that is the end of the for each for for the connection genes. And as you can see, it's very simple. You guys just have to make sure that you guys are passing all of its values from the gene. Okay, so all of the connections values should come from the connection genes. Okay, then we add it to the list, and that's done with the second loop. Now we look at the third loop. Okay, but okay, third loop. Let's write this down. Now the third loop is where things get a little bit more interesting, because for each node, then we need to go through for each connection. So this is the loop really where runtime starts to get annoying. But yeah. And then so we go through all our nodes, and we go through all the connections, and if a connection dot input node equals node dot input node, no, if a connection dot input node equals node dot id, then so let's then we do something. Let's write the outer loops first, and then we'll write the inner loops. So we do something if that happens, and we do something if the connection gene dot input node equals node id. We do something else. If the connection gene dot output node, because that's the two we have, equals node dot id, then we do something. Okay. But what is it that we want to do? Let's look at our code right here. So when the so we have a connection gene, right? And when the input of the connection gene, input is 1, so we want to set that as the input node for connection 4. And when the output, when for 1 output, it's harder to use this as an example since 1 doesn't have an input and output. We'll use 5. So for when we see that 5 shows up as an input node, right? That means that it's going to show up in this direction, going up to 4. So when an input connection ID is 5, the input node to a connection is 5, then we add it to the output node, I believe. Yes. Let me think about this, because this I want to make sure the logic of here is right, and this was a little confusing even before. So I remember this was a little tricky. I'm gonna have to look back at this paper. Yes. So if it's an input connection, so this is in for 1. So if it shows for each connection, if it shows as an input, then it's an output connection, because 1 is giving, this is going to be on the output side of the connection. It's not on the input side. Okay, that makes perfect sense. Sorry about that, guys. It took a little second. I appreciate you guys being patient and staring at code while I figured that out. Hopefully you guys figured that out 2, and hopefully we're on the same page, which is that for each node, when our connection gene input node equals node.id. So for example, when our connection gene input node equals 1, we want to add it to the output connections of 1 because it's on the output side up on top. Alright, this part is a little confusing. Alright, so I hope you guys take a look at it and make sure you understand why that it's reversed. Alright, so node dot input connections, node dot output connections dot add con. So we add the connection into the output connections, and then node dot input connections dot add con. So we add, if the connections dot output node equals node ID, then we know that that's on the input side. Okay, and you see that right here. For 4, we see that the output for 4 is 5, right? So you said out 5, but that's on the input side of the connection because 5 is giving information to 4. So it's on the input side of the connections, and therefore gets added to the input list. Alright, that makes good sense. And yeah, so that's about it for these 3 loops, right? And that's about it for our creation of a network. These 3 loops right here basically do everything for our creation of an empty network, right? We initialize a network right here because this is where our genomes gets created, but the creation of the network is automated based on the genome. So if I create a connection gene right here, that will get created in the network, right? So anything I could change this to change how I manually add connections to this part right here, and that will follow through into the network. All right, let's see if there are any errors. Nope, everything is looking fine. So yeah, let's see what our next steps are from here now. I believe our recording has gone pretty long today. I am going to cut this recording, and then I'm going to start a new one.